So let's look at this one. A country has a growth rate of 4.4% per year. The population is currently this number, 5,554,000. And the land area of the country is 39 billion square yards. Okay. Assuming this growth rate continues and is exponential, after how long will there be one person for every square yard of land? So anytime you've got these types of problems, really what you need to do is write down what you know. Is this exponential growth or decay? Growth. Increasing, right? So it's growing. So let's talk about that formula for exponential growth. That formula is P of t equals P naught e to the kt, where P naught is your initial, right? Do I have some of those things that I already know? What do I know? The P naught. What is the P naught? 5,554,000. See how that's the initial right there? So I know that P of t equals P naught is the 5,554,000 e to the kt, right? Do I know my k? What's k stand for again? The growth rate. So do I know my growth rate?
4.4%.
How do I write 4.4%?
0.
And then t, I don't know the time though, right? Okay, so what is that? So I just copied down by plugging in everything I know. Let's read the problem again. Always read the problem multiple times. Okay. So I've got a country that's growing at 4.4% per year. Okay. Their population is currently 5,554,000. And the land area of the country is 39 billion square yards. Assuming this growth rate continues, how long will it be until there is one person for every square yard of land? So if I want one person for every square yard of land, how many people is that?
5.
Like an exact number. You can give me an exact number. How many square yards of land is there?
39 million.
39 billion.
Billion.
And I want one person for each of those. So how many people is that?
Billion.
39 billion. So I want my people, my population to be 39 billion exactly. So I want this to equal 39 billion. So 39 billion. Did I do the right number on zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 zeros. Equals 5,554,000 e to the 0.044t.
Where did we get the e from again?
From the formula. That comes straight from the formula.
Oh.
Yep. Now I got to solve for time, right? Because it's asking me to solve for time. So I need to get the e by itself so I could take ln of both sides. How do I get the e by itself?
Divide 5,554,000.
It's really funny how we're really struggling with big numbers, don't we? So 39 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Oh my gosh, I wrote 9. Divided by 5,554 with 3 zeros equals e to the 0.044t. Right? What's nice is, then what could I do?
ln.
Take ln of both sides. So when I take ln of both sides, let me go over here. So I got ln of 39 all over 5,554 equals, and this ln and e went away, right? So on this side, what did I have?
0.044t.
And again, what are we trying to solve for?
Time.
So I need to do
Divide by 0.044.
right? That would go away, and that would give me my time. Now that I'm done with the problem, that's when you plug it all into your calculator. So let's plug that into our calculator. So I'm going to do the ln, and then I've got this parentheses, 39 divided by 5,554, end that parentheses, and then divided by 0.044. You should get an answer. I got 201. That's what I got. 201 what? Years, right? We're talking about years. Talking about time. So in 201 years, I will have 39 billion people in that country. It's a little disconcerting, right? Degrees to start, and we had to put it into a temperature that had 0 degrees. So my surroundings was T naught. That was the 0 degree freezers. The actual object I'm dealing with is the T1. That's the 145 degrees. Plugged it into the formula. That formula is given to us right there. I simplified that formula. Then the problem told me that after 15 minutes, so time was 15, the temperature was 43. And then I used this to solve for K.
How can it end up being a negative K? Because they did negative divided by negative.
Oh, if I did plug this in, it would have simplified out that way. I just didn't plug into my calculator, so I didn't know the decimal.
Okay.
But yeah, it would have worked. Yeah, she already did, so she realized, but yeah, it would have. So once I solved for K, now I could take that K value, and here's how you solve for K. You divide it by 145, you took ln of both sides, and then you divided by the negative 15. And I took that, and I now replugged it back into my formula, and that formula came from here. Okay. And then all I had to do was plug in 20, because the question asked for 20 minutes, and that gave me the temperature after 20 minutes. Ta-da. Okay, so you have temperature discovered a body of a murder victim. Critical to solving the crime is determining when the murder was committed. The coroner arrives at the murder scene at exactly 12 p.m. Okay. She immediately takes the temperature of the body and finds the temperature of the body to be 94.6 degrees Fahrenheit. Right? Okay. She then takes the temperature 1 hour later and finds the temperature to be 93.4 degrees Fahrenheit. The temperature of the room is 70 degrees Fahrenheit. Does it make sense that the temperature of the body is getting colder? Because the surroundings of the body are colder, right? And your body right now stays at 98.6 because you have blood flowing through you. So the surroundings doesn't affect you. But when you don't have blood flowing through you, not to be so gruesome, but so when the body is dead, the body starts to decrease in temperature. Does that make a little bit of sense? So let's plug in everything we know. Let's write down everything. What is
we're trying to solve, so let's go ahead and continue on writing down everything that we know first. So we want to first be able to figure out what our T naught and what our T1 is. So remember, from the formula, T naught is the surrounding temperature, so that would be the temperature of the room around the body, and T1 is the temperature of the body. And what we're going to do this time is we're going to talk about the temperature when I first walked in there. I, as the coroner, first walked in there and checked the temperature of the body, and I got a temperature of 94.6. So that's going to be our T1. So now we're going to use that information and see what we can do to plug that into our formula. So this is our Newton's law of cooling. Let's just write that down one more time. We have T of T equals T naught plus T1 minus T naught times E to the negative KT. And we'll go ahead and plug in everything that we know. Always want to plug in what you know first. So let's go ahead and do that. That's going to give me T of T equals, now my T naught was 70 plus, and now I've got the 94.6 minus 70 e to the negative KT. And then the next bit of information it gives me is that the next temperature that I take is 1 hour later. So that would mean my lowercase t was the 1 hour, and then the capital T would be this new temperature, and that new temperature was the 93.4. So let's go ahead and do that. Let's plug in everything we know, and we can simplify our formula along the way as well. So this capital T, we know this new temperature is now the 93.4. That was the new temperature after 1 hour. And this is 70 plus 24.6 e to the negative kt, and that lowercase t is 1 for 1 hour. And what we're trying to do here is we're next going to try to solve for K, because we want to know the rate of change for this the temperature of this body. So in order to do that, we got to get E by itself first, so that way I could take ln of both sides. So that's the first thing that we're going to do. So in order to get the E by itself, I have to first subtract the 70 from both sides and see what that gives us. And then you're going to have to end up dividing by the 24.6 as well. So we ended up with 23.4 equals 24.6 e to the negative k. Divide both sides by the 24.6 to simplify that equation even more. And that would give me 23.4 divided by 24.6 equals e to the negative k. And then what you do from there is you have to take ln of both sides. So when you take ln, you have to do that of both sides. And the reason we're doing that is that's going to simplify our equation. This is how we solve exponential equations. Alright, and so then we're going to end up with ln of 23.4 over 24.6. And you could plug that into your calculator now if you'd like, but you certainly don't have to. This ln and e, that we know that property of logarithms will simplify into just that negative k, which then gives us that k equals negative ln of 23.4 all over 24.6. So now we know what that k value is. What we have to do is then rewrite our formula one more time. So let's rewrite that temperature formula using the Newton's law of cooling is what we've got. So I ended up with, now I have T of T equals 70 plus, and again we had that 94.6 minus 70, which simplified into the 24.6 e to the negative k times t. And so inside that k, what's going to go there? That's going to be that negative ln, and we had the 23.4. This might not fit. 23. Let's actually, let me erase that so I can make sure I have room. Okay, so this gives us the ln of 23.4 over 24.6 times t. Okay, so I've plugged in basically just everything that I know. So always the first thing I did was just plugged in what I know. Okay, and so then what we do is we want to figure out the time. We're trying to solve for time because we want to know the time of the murder. So what we want to know is the time the body was last alive. And the time the body was last alive was when the temperature of the body was 98.6. That's the best estimate that we know for the human body, is that the living temperature of the body is 98.6. So that's going to be our capital T, the temperature we want it to be at, because we want to know the time at which that temperature was 98.6. So this capital T was 98.6. Equals 70 plus 24.6 E, and now those two negatives will cancel, and that'll give me ln of 23.4 over 24.6 times time. And then what we have to do is solve for time. So that's the same way actually that we solved for k previously. First subtract 70, and then divide by 24.6, and so on. So the same idea. We're going to end up with 28.6 divided by 24.6 is going to equal to e to the ln of 23.4 over 24.6 times time. And then again, we're going to have to take ln of both sides, because what we're trying to do is we're trying to solve for time, and that's in our exponent. So we're going to have to take ln of both sides. Let's go ahead and do that. So we'll do ln on both sides, and how is that going to give us our answer? So this will give us then ln of 28.6 over 24.6 equals ln of 23.4 over 24.6 times time. So what we need to do is we need to plug those two numbers into our calculator, and we're going to have to simplify this to solve for time. So as you know, if those two ln's are simply just numbers, once I plug them into my calculator, I would get just a number. So what could I do to solve for t? All we would have to do is divide. So this is still the 28.6 over 24.6 divided by ln of 23.4 divided by 24.6. So this is what we need to plug in into our calculator to solve for time. So let's actually go ahead and do that. Let me show you how you want to do that on your calculator. Okay, so you have to find your ln button first. So ln, make sure that parentheses is there. It's important. And so then go back to figure out what it is that we're trying to plug in. So let's actually do this. We want to plug, whoops. We want to plug this into our calculator. So we've got the 28.6 divided by the 24.6, and then you have to close your parentheses, just as this parentheses was closed. And then the divided by, and then we're going to do the same thing, ln of 23.4 divided by 24.6, and again close that parentheses, because this parentheses right here is closed. And then let's see what we got. Alright, so what I ended up with was -3, approximately. Let's round that, go ahead and round that to -3. So I ended up with time is equal to -3. So what does that mean? What that means is I got 3 hours, but the negative meant previous 3 hours. So that meant 3 hours ago. So my murder was committed approximately 3 hours ago. Ta-da!